So this is group two. My name is Aiden Jones.
My name is Fallon Kishman Heath.
My name is Caitlin Gamble.
And I'm Najiba Camel. So for our program, we've decided to create a functional Connect 4 game for 2 players. So in this game, the players are allowed to choose the size of the board, and then after that, it prompts the users for the column that they want their chip to be placed in. And whoever connects 4 of their chips in either a row, column, or diagonal first wins.
All right, and here's a little functionality demo of the program. So first off, I started the program by getting Connect 4 in the diagonal right direction just to show that it actually works. And after that, I just show that if you type in any number that's outside of the bounds of the actual potential size of the board, it reprompts. And right here, I show that even if you get a Connect 4 that's not in a linear sequential manner, it still works. So it's not just if you get 4 in a row straight up. And right here, I just show that if you type in a negative number or a letter, it reprompts you for any of the prompts right here. And then after this, I'm going to restart the program and then show that if you fill up an entire column and then try to select that column again, it reprompts until you select a valid column. And yeah, that's the functionality of our program.
So we knew going into this project that the board would have square dimensions and that we would need to prompt the user for the integer dimension. As the program runs, it also will print the number of pieces that the current user has placed and the maximum number of connected pieces to the console. And the game continues until 4 chips from the same user are connected in any direction. The additional capability that we added was to allow the user to enter in whatever board size that they wished.
We originally came up with 2 design options. For the first design, it would have 2 classes, user A and user B, that would contain information about each user's individual chips. The pros of this was the client class handled most of the functionality, but the cons were that our 2 classes were too similar, and the project required having multiple classes that were not as similar as ours were. Our second design option was a board class and a pieces class, and the boards class would deal with outputting, checking, and updating pieces, and the pieces class would hold all the information about the pieces. The pros of this is by moving the functions of the board from the client's class to its own, it simplified the layout and it made the code easier to read. The cons was we did not prefer having the pieces contain all of the information relating to the pieces. It took the same amount of code that it would do for design 1 to do user A and user B, but it just put it all in one class. And so it'd be the same amount of code regardless.
So for our final design, we decided to do a mix of both design 1 and design 2 by keeping the user A and B classes and incorporating the board class. So the board class controls the board functionality, such as checking if the board is full, adding pieces to the board, checking that the top of the column is null, and printing the output of the board. The client class prompts the user for the board size, so it outputs the max pieces connected and total pieces for each player, and whether which one wins. And then user A class checks to see if the position of player A's chip is in the X position or which Y position, left diagonal, and which right diagonal. And then user B class checks for the same thing just for the player B.
For the lessons learned during this, we learned the importance of pivoting while coding. For example, with our design options, when design 1 and design 2 did not fully meet what we wanted, we found out a way to combine them both to improve the functionality of our code and keep it more efficient and easier to read. During this, we also learned the difficulty of writing tests on our own without anything to base it off of, because for most of the labs and projects, we've had some sort of basis of code or an example, and this allowed us to be a lot more intentional and understand our coding and the testing itself a lot better.
As we implemented the extension component of our project, we ran into problems with the columns and the column numbers not lining up once the number of columns reached double digits. So to fix this, we removed the numbers underneath the columns once the number of columns exceeded 10. And you can see this in the before picture as after the 10th column, the numbers begin to run off the page to the right. And in the after image, you can see that we just removed that once the number of columns exceeded 10. We had also forgotten to increase the number of connections needed to win based off of the board size, but we were unfortunately unable to fix that due to time constraints.
All right, and for purposes of testing, unit testing primarily focused on the user and board classes because the system tests handled most of the equivalence classes and testing bounds because the system test plan deals with a lot of the user input. And yeah, we can switch over. Okay, so on the left here, we have an example of a test from the user class. So we instantiate a board object and we begin to place pieces as we desire in a specific format. And this is specifically for the diagonal left connect test. And then we instantiate a user object at the location that we need it, and then we update it. So then we can compare the max connects, which is a static variable of the maximum connections of that class, which should be 3 connections between 4 pieces. And then the same thing where we get the connections from the actual piece that we placed down. And then over here on the right, we have examples of tests from the board class. So we instantiate a board object for the test board out, which actually tests the display output. So we place pieces down and then we call the board out function. And then we compare its output to the expected string, which it should be. And then also for add piece, we add a piece using the board method. And then after that, we compare at the specific location that we expect the piece to be, whether or not it's null. And really, this is how we navigated all of our tests with the user and board classes by adding pieces and checking expected results. So right here is a system testing. This is where all the user input is tested, and we actually check to see the win conditions. So yeah, and that's how we test our equivalence classes and our bounds.